Welcome to Nutley Cisco Academy. Today, our topic is dividing the local network.
Okay, so selecting a path and how with routers. When a router receives a frame, it decodes this frame in order to get the packet containing a destination IP address. It'll then match the network portion of this destination IP address to the networks that are listed within this routing table. If the destination network address is in this table, the router will then encapsulate the packet with a new frame to be sent out. It will then insert a new destination MAC address as well, and then it recalculates the frame check sequence field, which is an error detecting code that's added to a frame in a communications protocol into a new frame. It forwards the new frame out of the interface associated with this path to destination network. Then this process of forwarding the packets towards the destination network is called routing. Router interfaces do not forward messages that are addressed to the local network broadcast IP address. As a result, the local network broadcasts are sent out across routers to other local networks. And here's an example of this with these pictures.
Routing tables, they can be maintained manually or dynamically. Ables for static routing devices do not change unless the network administration manually changes them for things such as device failures and network congestions. And dynamic routing devices build and maintain their routing tables automatically by using routing protocols to exchange information. And dynamic routing tables allow devices to listen to the network and respond to occurrences about the surrounding network topology. A routing table is a set of rules that is used to determine where data packets traveling over an IP network will be directed, along with the best path towards its destination. It contains information such as the origin and destination that is necessary to forward the packet. A packet is received, and a network device examines the packet and matches it to the routing table entry, providing the best match for its destination, and the table provides the device with instructions for sending the packet.
Okay, so this is an example of the routing tables in action. Say that H1 needs to send a packet to an IP that's also in the local network, anything that's labeled H. The IPv4 and MAC addresses are in the ARP table, and it will forward it directly. The IPv4 and MAC addresses are in my ARP table, and I'll forward it directly in the person of H1. The addresses are in my ARP table. I'll forward it directly, and it goes straight to H3, or the IP address 192.168.1.3.
So a basic routing table includes the following information: a destination, which is the IP address of the packet's final destination; next hop, which is the IP address to which the packet is forwarded; interface, which is the outgoing network interface the device should use when forwarding the packet to the next hop or final destination; metric, which assigns a cost to each available route so the most cost-effective route can be used; and routes, which includes directly attached subnets, indirect subnets, and default routes to use for certain types of traffic.
All right, so LAN. Stands for a local area network. A local area network is a computer network that interconnects computers with a limited area, such as a residence, school, laboratories, university campuses, or office buildings. And there are three types of LANs. They're called topology, protocols, and media LANs. Okay, so some examples of LAN networks include a video game tournament. So say in an esports event, there'd be 10 different computers, but they're all connected to the same network. So they get the lowest input lag and everyone is on the same network. Or if you're playing a game with your friend at a house, so say if you have two Nintendo Switches, you'll connect them together and they'll be on the same network. Or an office network where everyone's hundreds of employees can be connected to a single network and they're all connected together.
Question 1, what do routing tables contain? Question 2, what are 2 ways routing tables can be managed? 3, what happens when a routing table is maintained dynamically? Number 4, how does a router interpret a routing table when receiving packets? Number 5, what does LAN refer to? 6, what are some common characteristics of LANs? 7, what are some examples of LAN networks? 8, all local area networks are under whose control within a LAN network?
And the answers to these questions can be found in the link below in the description. Thanks for watching. Make sure you like, comment, subscribe, and remember, that's how Cisco works.